Hello, calculus fans. Let's take this equation, x squared plus y squared plus z squared minus 6x plus 5y plus z equals 57 over 2. Let's take that equation and show that it's actually an equation of a sphere, and we'll find its center and radius. Now, it's not obvious that it's an equation of a sphere. It's got some of the elements involved, got the x squared plus y squared plus z squared, but at the moment, these terms here should bother you a little bit. What we're going to do is we'll rewrite this equation a little bit, and then we're going to complete the square. So our goal is to complete the square on each variable. So for instance, we'll collect all the x's together and complete the square, and the y's and the z's. When we take these x's and we complete the square, we have a method for doing this. We take the coefficient on the x term, which is -6, divide by 2, that gives us -3, and then we square that number. That gives us 9. So we're going to add that to both sides of the equation, and that'll create a perfect square. We'll do this for each one of the variables. Let's see what we get as a result. So what you should see here is that we've added 9 to both sides of the equation because that completes the square on the x's. Let's see, where does 25 over 4 come from? Well, same way, we take the coefficient on the y, divide by 2, that gives us 5 over 2. Square that and we get 25 over 4. That has to get added to both sides, and so that's why you see a 25 over 4 over here. All right, can you see how we got the 1/4? Well, what's the coefficient on the z term? It's 1. Take 1, divide by 2, and you get 1/2. Take 1/2 and square that, and that's how you end up with the 1/4. And it has to get added to both sides because you have to balance your books. You cannot put a number on one side of the equation without putting the same thing on the other side of the equation. When you piece all these together, this perfect square, x squared minus 6x plus 9, turns into x minus 3 quantity squared. Each one of these collections turns into a perfect square, which is exactly what we want. Now we can recognize the final result as being the standard equation of a sphere. We should be able to see that the center is 3, -5/2, -1/2. And the radius is square root of 44, which is the same thing as 2 root 11. Either way is fine to write that. One thing you don't want to do with this radius is stick it in your calculator and get some decimal. That will only be an approximation. In this class, we always want to use exact value. 2 squared 11 or square root of 44 is an exact value. Anything that you might get out of your calculator is necessarily an approximation. There will be times when approximations are appropriate. Without any sort of instruction otherwise, you should assume that the question wants exact value. Okay, that's all for now.